Assalamu alaikum and welcome to Cambridge Chemistry channel with Sarbat Ahmed. Today I will solve chemistry paper 1 multiple choice Feb March 2023 9701 paper 1 2. Let's start. Question number 1. Question number 1, four equation uh, representing reactions of nitrogen of one of its compounds are given. Which equation represents a disproportionation reaction? Uh, Nitric acid and calcium carbonate. This is neutralization reaction, so this is not redox. Nitrogen and hydrogen to form ammonia. This is also not redox. This is redox, but not disproportionation reaction. So it is also incorrect. Ammonium chloride, sodium hydroxide to forms NaCl and water. This is also not disproportionation reaction, so it is also incorrect. Uh, Option D is correct because nitrogen is oxidized and reduced at the same time. For example, over here nitrogen is -2 and nitrogen is +4 over here, and in this case -2 3 to the 6 +5 in this case, and HNO2 is here is -2 HNO2. Look at here, HNO3 is equal to 0, hydrogen 1 plus nitrogen X plus 3 minus 2 is equal to 0. So X minus 6 plus 1 is equal to 0, so X is equal to +5. So here +5, and in this case HNO2 is equal to 0, 1 plus X minus 4, because 2 minus 2 is equal to 4. So 1 plus X minus 4, so X is equal to -3 is equal to 0, X is equal to +3. So in this compound +3, and this is +5, and nitrogen is +4, so this is oxidized and HNO2 is reduced. So this is disproportionate reaction. Question number 2. The diagram shows Boltzmann distribution for 1 mole of gas. The gas takes part in the reaction with an activation energy EA. Which statement correctly describes the effect of an increase in temperature? Peak P will be higher and fewer molecules will have energy more than activation energy. Increase in temperature. Which statement correctly describes the effect of an increase in temperature? P will be higher. No, P will not be higher. So this is incorrect. Peak P will be higher and more molecules will be. So by increasing temperature, peak P will be lower, like this. Peak P will be lower. So these two options will discard these two options. Peak P will be lower and molecule will have energy more than activation energy. Fewer, not fewer molecules, more molecules. So this option is also incorrect. So D option is correct because P will be lower and more molecules will have activation will have energy more than activation energy. So this D option is correct. Question number 3. A student carries out four experiments to investigate the rate of reaction between uh, 3 gram of calcium carbonate and hydrochloric acid. Calcium carbonate and hydrochloric acid to form calcium chloride plus carbon dioxide water. Experiment 1, calcium carbonate powder 2 mole and the temperature is same. To concentration is 2 mole per dm cube at 35 degrees centigrade. Experiment 3, large chips of calcium carbonate and concentration is also same in both cases, but experiment 4 temperature is at 35 degrees centigrade. Now the student collects carbon dioxide and times how long it takes to produce the same volume of gas for each experiment. What could be the correct times for 4 experiments? Uh, Experiment 1, A option, experiment 1. A option, yes, this is correct, this is correct, this is correct. Because in A option, concentration is more, calcium carbonate is in powder form. So in powder form, the rate of reaction is faster at 35 degrees centigrade. For experiment 5 is also correct. 5 this, but look at experiment 2. Experiment 2 is same, calcium carbonate powder 2 mole per dm cube, HCl at 35 degrees centigrade. In this, these two options should be incorrect because the same condition not taking too much time, so this option is these two options are correct. Experiment 3, taking more time because large chips of calcium carbonate is used in this case, and hydrochloric acid at room temperature. So at room temperature taking more time, so it must be 95. So now experiment 4 will decide the correct option. So next, experiment 4 is 95 degrees centigrade, 95 second. Experiment 4 temperature is increased even though large chips of calcium carbonate and same concentration is used, but increasing the temperature, so it will take less time. So it must be correct. Not 10. 10 is too small time. 5 is also, this will be appropriate because large chips of calcium carbonate is used. So option B is correct. Question number 4. The table shows the partial pressure in an equilibrium mixture formed by the Haber process. Hydrogen plus nitrogen to form ammonia. Substance partial pressure is kPa. Nitrogen, hydrogen, ammonia. 7,000, 8,000, and 4,000. What is the numerical value of the equilibrium constant Kp for this reaction? So Kp pressure, first write down the Kp pressure, partial pressure is given. So we use direct uh, these values in Kp expression. So this is partial pressure of ammonia, product divided by reactant, hydrogen, partial pressure, and nitrogen, partial pressure of nitrogen. So Kp is equal to ammonia is 4,000 into 4,000 divided by H2 8,000, 3 times 8,000 into 8,000 into 8,000, and one time is nitrogen 7,000. So this is, we cancel out, and now 4 into 4 divided by 8,000 into 8,000. So this is, by calculating, the A option is correct. Question number 5. A reversible reaction is shown. 2NOCl to form, add 2NO plus Cl2. which change, this is endothermic reaction, which change in conditions will move the position of equilibrium to the right and increases the value of equilibrium constant. So Kc is only, we know that Kc is only temperature dependent. So equilibrium constant is only increases by increasing temperature. Decrease pressure incorrect, decrease in temperature incorrect, and increase in pressure incorrect. So Kc is only increased by increasing temperature, as it is temperature dependent. Question number 6. The ore um, silomylane may be considered to have the general formula. Uh, in its general formula, X plus Y plus are the two different oxidation states of manganese in silomylane. What could be the value of X and Y? Barium has plus 2 oxidation state. So write down over here plus 2 plus MnX plus MnY 8Y plus minus 2 16 minus 2, and this is minus 1 OH, and plus 4 minus 1 is equal to 0. So plus 2 plus X plus 8Y minus 32 and minus 4 is equal to 0. Now how to decide that what would be the oxidation state, what would be the values of X and Y. So let's know that minus 2 minus 3 is minus 36 and 8Y plus X plus 2. So X plus 8Y minus 34 is equal to 0. So 34, if we take this value, these two values should be equal to 34, because x plus 8y is equal to 34. These two values should be equal to 34. So if oxidation state of 8 y is plus 4, so 8 into plus is equal to 32, and what would be the now x? So x would be 2, so in this case this is equal to 34. So we can predict that 4 positive 4 would be at plus 4 at mny, and plus 2 would be mn. So option 2 and 4 is correct. Question number 7. Silicon reacts with a mixture of calcium oxide and magnesium oxide at 1200 degrees centigrade. Which statement about this reaction is correct? Calcium is reduced and silicon is neither oxidized nor reduced. Calcium is reduced. Over here plus 2, over here plus 2. So calcium is not reduced, because in this case calcium and silicon is neither oxidized. Over here 0, and in this case calcium silicate 2 into plus 2 plus x plus minus 4 to the 8 is equal to 0. So 4 plus x minus 8 is equal to 0. So x minus 4 is equal to 0. So x is plus 4. So silicon is in this case oxidized. So nor oxidized, so this is incorrect. Magnesium is reduced and calcium is neither oxidized nor reduced. Magnesium over here 2 plus and over here 0. So magnesium decrease in oxidation state after gaining of electrons, so it is reduced. And calcium neither oxidized nor reduced, so B option is correct. Magnesium is reduced, this is correct. Silicon is neither oxidized nor reduced, this is incorrect. Silicon is reduced and calcium is neither oxidized nor reduced. Calcium is neither oxidized, so this is incorrect. Silicon is oxidized, so B option is correct. CH3 has one electron. CH4 is positive charge, methyl radical over here, positive charge. uh, so no lone pair. CH3 has lone pair. This is carboanion, this is carbocation, this is carbocation, so no lone pair. This is carboanion, so it has lone pair. And CH4 complete bonded, so carbon has 4 electrons, fully bonded with 4 hydrogen atoms, so that's why it has no lone pair of electrons. The C option is correct. Question number 9: under which conditions will need a nitrogen behave most like an ideal gas? So this is ideal gas equation: high temperature and low pressure. High temperature, mostly gases behave as an ideal gas. At high temperature, low temperature, these are the conditions, so B option is correct. The equation for a chemical reaction is shown. All substances are in their standard states. XCF, which statement describes standard enthalpy change of reaction for this reaction? All enthalpy change when a total 1 mole of product is formed. Yes, this is correct option, because enthalpy change of reaction when 1 mole of product is formed is produced, total of 1 mole of product is produced, so this is A option is correct. When total of 1 mole of reactant is reacted, no, 1 mole of product is produced, so this is incorrect statement, so B option is incorrect. The enthalpy change when 1 mole of water reacts, no, enthalpy change when 1 mole of water, this is also incorrect. Enthalpy change when 6 moles of hydrogen chloride are produced, no, this is also xenon trioxide, so this is also incorrect, so A option is correct. Enthalpy change when total of 1 mole of product. Question number 11. Molten aluminum chloride has a simple molecular structure. Each molecule consists of 2 aluminum atoms and 6 chlorine atoms. Which statement is correct? All the chlorine atoms in 1 gram of molten aluminum chloride have the same mass. No, this is not correct. 1 mole of molten aluminum chloride contains 6.02 into 10 raised by 23 aluminum atoms. 1 mole of molten aluminum chloride. So aluminum chloride has 2 aluminum chloride atoms and 6. So it is about 1 mole of chlorine atom. So this is also incorrect. 1 mole of aluminum chloride contains 3.61 into 10 raised by 24 chlorine atoms. So we have 6 chlorine atoms in the questions. So 1 mole of molten aluminum chloride, like 1 into 6 into 6.02 into 10 raised by 23. So this option must be correct. 1 mole of aluminium chloride contains 3.61 into 10 raised by 24. So this is equal to 3.61 into 10 raised by 24. So C option is correct. The empirical formula of molten aluminum chloride is Al2Cl6. This is incorrect. Empirical formula is AlCl3. The option is incorrect. Which atom contains 4 times as many neutrons as the lithium atom? Which contain 4 times as the 4 times 3 3 is a 9 and 3 this is 20 neutron, 15, 12, 24, 4 times. So, so 4 times of neutrons. So in this case, neutrons will be neutrons in lithium atom. Neutron will be 4 neutron, and in this case 20 neutron, in this case 12 neutron, in this case 16 neutron. So 4 times neutrons are more. So this is, I think so, 4 times more neutrons, many neutrons as a lithium atom. C option is correct. Over here 14, 26, 2 and 12. So C option is correct option. Which statement about the first ionization energies of magnesium and neon is correct? Magnesium has the greater numerical value, and both are endothermic. Magnesium has greater numerical value and both are exothermic. Magnesium and neon, first ionization energy. Magnesium has the greater numerical value and both are neon. No, this is incorrect. Neon has greater ionization energy. Magnesium has the greater numerical value and both are exothermic. Exothermic is incorrect, so it is also incorrect. Neon has a greater numerical value. This is this is correct statement value, and both are endothermic. Yes, both are endothermic. Ionization energy of magnesium and neon both are endothermic, but neon has a greater numerical value than the magnesium. C option is correct option. In a simple question number 14, in a sample of pure water, what is the maximum number of hydrogen bonds that one molecule of water can be involved in? So how to determine the number of hydrogen bonds? For example, we have pure water, H2O, 2 atoms of hydrogen and 2 lone pairs, 2 lone pairs and 2 hydrogen atoms. So similarly, nitrogen has one lone pair, 3 hydrogen. So we know that hydrogen atom when directly bonded to nitrogen and fluorine, fluorine and oxygen determine the hydrogen bond. So we have two factors which determine the hydrogen. One is the lone pair, another is the hydrogen atom. So in the if the lone pair and number of hydrogen atoms are equal, so less quantity determine the number of hydrogen, whether it is lone pair or whether it is hydrogen atom. So in nitrogen, 3 hydrogen bonds and 1 lone pair. So ammonia per molecule has 1 hydrogen bond and H bond, while in this case 3 lone pairs surrounding chlorine atom while 1 hydrogen atom. So this is 1 hydrogen bond per this molecule. So in this case, 2 lone pairs and 2 hydrogen pairs. When lone pairs and hydrogen atoms are equal, so total number of bonds, hydrogen bonds are 4. So D option is correct. So if lone pair and hydrogen atoms are equal, so this will be total, and we have 4 hydrogen bond in water molecule as compared to ammonia. Ammonia has 1 lone pair, 1 hydrogen bond, while fluorine has 1 hydrogen atom. So this is hydrogen atom is less, so lesser quantity determine the hydrogen bond. And if both are equal, lone pair and hydrogen atoms are equal, the total lone pair and hydrogen atom determine the hydrogen bond. So we have 2 lone pair, 2 hydrogen. The total number of hydrogen bonds are 4. So that's why D option is correct. Hydrated cobalt 2 sulfate loses water when heated to give anhydrous cobalt 2 sulfate. All the water of crystallization is lost to the atmosphere as steam. When 3.10 gram of hydrated cobalt sulfate dot XH2 is heated constant mass, the loss in mass is 1.39. So this is total mass, and this is first calculate the total mass of water and mass of cobalt. So cobalt sulfate and water. We have water mass is 1.39 and cobalt mass is 3.10, 1.39. So 1, 10, 7 and 2. 1.71 is over here. So cobalt calculates the mass of cobalt sulfate. So we have cobalt mass is 58.9. Cobalt mass is 59.8.9 plus 32 plus 64. This will be 64 plus 32 plus 58.9 is equal to 154.9 divided by 154.9 divided by 18. So 151.71 divided by 154.9 is equal to, so this is equal to 0.011103, and this is equal to 1.39 divided by 18, which is equal to 0.077. So 0.010, so finding out the number of moles, like 0.01139 divided by 0.011039. So this is equal to 1:7 ratio. So whole number water molecule would be constant loss. And what is the value of x? So value of x is 7. The table shows bond energies for some diatomic molecule is an isotope of hydrogen. These are the bond energies. Deuterium is an isotope of hydrogen. Which statement are correct? The table shows energies for some diatomic molecule. Deuterium is an isotope of hydrogen. Which statements are correct? Diatomic molecules have exact values for their bond energies, which are always positive. Yes, diatomic molecules have exact values for their bond energies, which are always positive. The trend in group 7 bond energies can be explained by the variation in instantaneous dipole induced dipole. So this is incorrect. Bond energies can be explained by variation in instantaneous dipole. A value of for the, so hydrogen deuterium is an isotope of hydrogen, so it is incorrect because this is not effect on this statement. The table shows bond energy. Deuterium is an isotope of hydrogen. Which statement are correct? Value for the enthalpy change for the reaction between deuterium and chlorine can be calculated using these data alone. Yes, this can be correct because chlorine HCl bond energy, like if this is Cl HCl, so a value for the enthalpy change for the reaction between um, deuterium and chlorine can be calculated using these data alone. Yes, this is also correct. It's also not correct. Molecules have exact values for their bond energies, which are always. So this value also, value for the enthalpy change for the reaction between deuterium and chlorine can be calculated using these data alone. No. So बॉन्ड एनर्जी जो है दैट इज द टोटल मीन जो है वो आपके पास होता है मीन इज इक्वल टू टोटल बॉन्ड एनर्जी. So diatomic molecules have exact values for their bond energies, which are always positive. So this is correct. Statement 1 is only correct statement. Question number 18. Powder P is a mixture of mixture containing 2 of AgCl, AgBr and AgI. P is shaken with dilute aqueous ammonia. A yellow solid Q remains. Yes, uh, because AgCl dissolve in ammonia and AgBr is also aqueous in aqueous ammonia, it dissolves. So a yellow solid Q remains. A yellow solid Q remains. The mixture is filtered, Q is washed and dried. The filtrate is cooled and treated with aqueous nitric acid. to produce a white precipitate R, which is filtered off, washed and dried. The filtrate is collected and treated with aqueous nitric acid to produce a white precipitate R, which is turned off, aqueous nitric acid and produce white precipitate, and which is filtered off, washed and dried. Q and R are warmed separately with concentrated sulfuric acid. So this is AgBr and Ag. Q is AgI and this is AgBr. So when this solution is treated with sulfuric acid, concentrated sulfuric acid, we know that Q is Q containing silver iodide, like we have seen in the syllabus equation, that Ni and NaBr when treated with sulfuric acid, NaHSO4 plus Hi, or similarly H2SO4 NaHSO4 plus HBr. So HBr, Hi and H2SO4 further reduced by Hi is oxidized by sulfuric acid and HBr. So possible products are we have bromine H2SO4. So with violet fumes for iodine. Iodine can also be produced, and orange fumes of bromine gas. So other possible products along with iodine and bromine. So this is experimental. This is the preparation of iodine and bromine. In this case, we can prepare iodine and bromine. So orange iodine is the violet fumes, and bromine is the has orange fumes. So these are the observation of these reactions. So other products are always produced in this reaction along with iodine and bromine in form of gases. So A option is correct for this question. Two periods, three elements, XY burn separately in oxygen to form solid oxides. The oxide of X is insoluble in water, Oxide of Y dissolves in water to form a solution which dissolves the oxide of X. What could be the, this is aluminum oxide, this is sodium oxide. So aluminum oxide is insoluble in water, while sodium oxide dissolve in water to form sodium hydroxide. We know that aluminum oxide is amphoteric oxide. So aluminum oxide dissolve in sodium hydroxide, can react with sodium hydroxide, dissolves in sodium hydroxide. So A option must be correct. X and X with B. Aluminum oxide is an amphoteric oxide which react with both acid and alkalis. So aluminum oxide is correct option. So sodium hydroxide is formed. Sodium oxide is dissolved in water. Magnesium oxide insoluble in water but cannot react with sodium hydroxide. This is incorrect. SiO2 P4O10. So both are acidic, so cannot react. Silicon and sulfur, both are nonmetals, form acidic oxide. So cannot react, cannot dissolve. A option must be correct. Question number 20. Which row describes the structure or bonding of sulfur dioxide and silicon chloride? Silicon is giant molecule, bonding is covalent. Silicon chloride not giant, covalent. B is the giant, covalent. Symbol covalent. So this option is correct. Question number 21. A sample containing 0.01 mole of anhydrous calcium nitrate is heated strongly until it fully decomposes. All the gas produced is collected and its volume measured at room temperature and pressure. What is the volume of gas produced? So calcium nitrate decompose to form calcium oxide plus nitrogen dioxide plus oxygen. So this reaction will be balanced. So we have 0.1 mole ratio 0 to 2 moles and 0.5 moles. So this is 2.5 moles and 0.010 ratio x. So we have mole of gases are 2.5 into 0.01. 2.5 into 0.01 is equal to 0.025. 0.025 multiplied by 24,000, which is equal to 600 degrees centimeter cube. So B option is correct. V and G are both elements period 3 periodic table. Each element forms one stable ion that does not contain another element. The atomic radius V and Z are both. Each element forms one stable ion that does not contain another element. The atomic radius of each element and the ionic radius of the ion described above is shown. Atomic radius is 0.186. An ionic radius, second V element has 0.186 and ionic radius is 0.095. It means and Z has 0.099 and 0.181. And we know that cationic metal atoms have higher radius, atomic size, larger atomic size than the non-metals, and anionic radius is more than the cationic radius. So V is the metal and this is metalline, cation. This is non-metal and this is anionic radius. Anionic radius is larger than the cationic radius. So which statement is correct? Ions of V and Z have the same number of full electron shells. No, this is incorrect. Ions of Z are positively charged. No, this is negatively charged. So this is incorrect. Z has a greater electronegativity than V. Yes, because electronegativity is increases across the period. So V is metal and C is non-metal. So non-metal has more electronegativity than the uh, metals. So it means Z is non-metal V is metal, Z has more electronegative than V. So this option must be correct. In group 2 of the periodic table, the properties of the elements and their compounds show regular change down the group. Which property shows a decrease from magnesium to barium? Magnesium to barium. The decomposition temperature of the carbonate. So this is not decreased, this is increased because down the group stability of more stable compounds, more lattice energy. So decomposition of uh, carbonates require more temperature uh, down the group. The decomposition temperature of the nitrates, so this is also incorrect because decomposition has more, decomposition of all metal compounds have same trends. The solubility of the hydroxides, solubility of hydroxide increases down the group, so it is also incorrect, increases down the group. So solubility of the sulfate decreases down the group. So D option is correct option. Four properties of beryllium or beryllium compound are listed. Which property is different from the property of magnesium or the equivalent magnesium compound? Beryllium reacts with oxygen when heated in air. Magnesium does not. This is incorrect. Beryllium, this is incorrect. Beryllium reacts with aqueous sulfuric acid to form metal sulfate. Hydrogen, magnesium does not. So this is also incorrect. Beryllium nitrate decomposes on heating to form metal oxide, nitrogen dioxide, oxygen. Magnesium nitrate does not. So this is again incorrect. So beryllium chloride reacts with water to form fumes of HCl. Magnesium chloride does not. Yes, fumes of HCl, beryllium chloride, because beryllium chloride is magnesium chloride does not react with water because magnesium chloride only dissolves solid in water. It dissolves magnesium chloride in aqueous form. This is solid, this is not react, but beryllium chloride essentially covalent compound. This react with water to form BeO and fume of HCl. So this is correct option. Which two formula correctly represents a pair of structural isomers? Structural isomers. This is like this: CH3, CH, CH3, and CH3, and COOH. And this is also the same compound, CH, CH3, CH3, COOH. This is incorrect. CH3, CHCOOH, CH3. So this is in the bracket, again convert this, and this is CH3. CH3, this is these are the same structure. CH3CH and CH3CH2, CH2. 1, 2, 3, 1, 2, 3, and 4. This is butanoic acid, and this is propanoic acid, HCH3. So this is incorrect formula because CH3 COOH. This is incorrect. So this, so D option is correct because it is the CH3 2 CH3, and this is the structural formula: 1 2 3 4, 2 3 and 4. So this D option is correct. Question number 26: which reagents and conditions would result in the formation of butane? Which reagents and conditions would result in the formation of butane nitrile? one bromobutane one bromobutane under heated under pressure with ammonia in ethanol. No, this is incorrect because in this case CH3 CH2 CH2 and CH2 NH2. So this compound is butyl amine is formed. So this is incorrect. One bromopropane. So bromopropane heated with potassium cyanide. This should be correct because this is propane and 1 2 3 4 and 4 carbon long chain is increased in this case, so this must be correct. Propanol heated with hydrogen cyanide and the presence of potassium cyanide. No, this is hydroxy compound is formed, so this is incorrect. Propanol also incorrect. So this option must be correct. B option is correct. So next question is A option is correct in this case because 27 compound XC7H13Br reacts with hot alcoholic sodium hydroxide produce two compound Y and Z. One reaction with bromine Y gives product C7H12Br2 which exists as mixture of four possible isooptical isomers. On reaction with Br2, Z gives product C7H12Br2 which is non-chiral. Br2Z gives Y gives product this or mixture of four optical isomers, and on reaction with Br2Z gives product C7H12Br2 which is non-chiral. What could X be? React to produce two compound Y and Z. Okay, Y and Z. Two compounds Y and Z. Look at this. Plus Br2. C7 react with hot alcoholic to produce two compound Y and Z. Y and Z like this. React with hot alcoholic plus sodium hydroxide. So this is BrCH3. Compound, this is elimination reaction. And if eliminate HBr, so we have two products are formed like this, CH3, and other product is like this, CH3. So when Br2 react, this product will be formed, CH2Br and CH2Br, and this product will be formed like this, Br, Br and CH3. So if this is further react with this and Br2 gives product which is non-chiral. Mm, on reaction with Br2, Z gives product C7H12 Br2 which is non-chiral. So CH2 CH2, this is non-chi. What could be Z? Z gives product which exists as on reaction Br2, Y gives products which exist as a mixture of 4 optical isomers, and on reaction with Br2, Z gives product Y and Z. These two are Y and Z, and this product Z gives a product which is non-chiral. This is non-chiral, and this would be, this is carbon, this is CH3, this carbon would be 1 2 3 1 2 3 4 CH2 and whole compound. This is chiral carbon. Z gives non-chiral, this is non-chiral, this is non-chiral, and this is chiral product, and Y gives, which exists as a mixture of 4 optical isomers. Yes, this can be optical isomers 4, like one compound is this Br CH3, and this is Br, this is H. Other is, this is one chiral Br H CH3 Br, and the other product is, other chiral compound is like this Br CH3 H and Br, and this is again A3C Br BH and Br. So this is the product of 4 chiral isomers, so A option. So that's why A option is correct. Other options would not give these two results, so A option is correct. So if you can try these compounds, but A option is correct because Y gives product which is non-chiral, this is non-chiral, and Z gives a product which have 4 opticals. Z gives non-chiral compounds while Y gives 4 chiral optical isomers. So next question is, So next question is when iodine S is heated under a flux with an excess of acidified potassium dichromate 6 compound M is formed. So potassium acidified potassium dichromate. This is a compound. This is tertiary alcohol, so this OH remain and double bond cannot react with acidified potassium dichromate. Which this is secondary alcohol gives O, and this is primary alcohol gives COOH. Now count the number of oxygen atom: 1, 2, 3, 4, and 5. So we have oxygen 4 over here because carbon is constant in all options. So oxygen and hydrogen are different. So over here 5. So we can D. So now count the number of hydrogen atom. Number of hydrogen atom over here 3. Over here C 1. 1 is this. Over here 1, 2, and no hydrogen, no hydrogen, no hydrogen, no hydrogen. This is 1, 2, 3. This is 1, 2, 1, 2, no hydrogen. This is again 3 hydrogen, no hydrogen. So 1, we count from here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is hydrogen 1, 2, and this is carbon. Wait, this is OH and this is carbon. So OH is formed over here. So 1 hydrogen, 2 hydrogen, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 carbon, 16 hydrogen, and this is